We're back to cover problem 8.18, which deals with an assembly line that produces an electronic component of a missile system that has historically had a 2% defective rate. And now we're taking a random sample of 800 components. And we want to know what is the probability that the defective rate is greater than 4%. So here we've got our normal distribution curve, which we'll plot something a little later, but we start out right up here with the idea that the probability of p hat greater than 0.04%. That's what we're trying to calculate. So here's the formula. It's got the p hat minus p, so I've got p hat equals to 0.04%. P, which is the defective rate, is 2%, and then we've got 800 in the random sample. So here's where we get it. It's p hat minus p divided by the square root of p times 1 minus p divided by n. So you can see it over here. It's the 0.04 minus 0.02 divided by the square root of 0.02 times 1 minus 0.02 divided by 800. And the idea of all of this is we change it into a z-score to standardize it, and then we can figure out what the probability really is. So the first thing I'm going to do is do this actual calculation. So in this case it's going to be equal to, and I'm going to put this in parentheses just to keep it easier to understand. It's going to be J4, which is the 0.04, minus J5, which is the 0.02. Close the parentheses, and then I'm going to divide it. I'm going to put this all in parentheses, and it's going to be the square root of, and in this case the number is going to be the 0.02 times 1 minus the 0.02, which is the J5 cell, divided by 800. Close parenthesis, and I'll hit the check mark to enter it. Oh, I didn't like something in there, but it did give me the correct number, which is a z-score of 4.04061. I mean, we can shorten this by just reducing the decimals to 4.04. So given that, what we want to say then is the probability of z being greater than 4.04 is equal to one minus the probability of z less than 4.04 equals. Now, just to show you the z-scores only go up to 3, right? So 4.04 is going to be somewhere way over here. But it's going to be 1 minus that. So the probability is going to, just one sec. Alright, sorry for the interruption. I'm back, and if we think about this, maybe we should take a look at page 310 in your textbook at the back, table 3, and you look at the z-scores, and you see that it doesn't go up to a score for 4.04, but basically if we look at the z-score for 3.0, it's 0.9987, or even that whole row, the largest number is the 0.9990. So basically the probability of a z being greater than 4.0, it covers the entire area of this normal distribution, which is 1. So basically what we're doing is then just simply taking 1 minus 1, which of course would be equal to 0. And from that, what do we learn? The other question on that problem 818, I lost my page for a second, so I just want to be accurate in stating it here, is suppose that in the random sample the defective rate is 4%. What does that suggest about the defective rate on the assembly line? The reality is then the defective rate on the assembly line is larger, appears to be larger than the 2% that was stated up here in P, because of the fact that it's 100% probable with a z-score of 0.404 that would be included. So in reality they probably have a larger defect rate than 2%. I hope that helps. We'll come back in a minute and do problem 820.